Welcome back to CAD/CAM tutorial. Today we are going to design a simple steel Almirah in Solidworks with the help of sheet metal tool. Here we will design mainframe, door and many things here, and we will assemble at the end. Now see, the door you can open and close. We will give some angle limitations to door, that 130-degree open and 0-degree close. See, that's fine, and we will give this simple annotation. I hope you like it. So let's see how to do in SolidWorks. Now here let's make the first part of Almirah is main frame or backside frame. So let's start with front plane, a sketch, and here choose center rectangle. Draw a rectangle, choose a smart dimension. Let's define it. We will define it 114.4 mm. This dimension took for due to some reference. (609.6 millimeter). This dimension we took due to some adjustment of tolerance and other dimensions. That's why we took this one. Now just go to sheet metal. Right click on command manager. Select here sheet metal. Go to sheet metal. Choose here base flange. Now we want to make the thickness. So make the thickness 0.6 millimeter. Let's see, it's going backside, so that's fine. We don't want to make a reverse. Backside is enough. Keep K factor as it is. It will calculate the dimension according to K factor. Okay, now that's it. Let's select here edge flange. Now select this face and choose this side, forward direction. Now select one by one all the front edges. The second one, here the third one, here the last one. Radius, let's first define the width. What kind of width we want to show it here, so let's choose 457.2 millimeter. Keep angle gap between 2.3 millimeter or 0.5 millimeter. This is the gap between these two frames. Radius, if you want to define something, let's define 3 millimeter is quite bigger, but that's fine. Use default, that's enough for this. Now here we want to keep sharp edge outer visual sharp edge. The sharp edge should be outside and the material should be inside. If you will see here, see, sometimes difficult to choose. Now look at here, the thickness comes inside according to material, so that's enough for us. Select here OK. Now see how it looks like, 3 mm radius and everything. Now let's go for the inside. Again choose edge flange and choose outside and select inside. See, it's going this. Now select all the outer edges, second, third. It will automatically took this wedge shape. The last one, choose it from outside edge. That's it. See, now here keep these things as it is. Now gap 0.5 it is asking, keep. It's up to you how much gap do you require in between. If you will keep less, then it's your structure will be fine. Keep 90 degree, the bend angle it's 90 degree, and the distance, how much do you want to keep? 30 mm. That's it. See, it's going inside. That's why if you choose forward, backward, so we want to keep inside, keep as it is, and this one is keep as it is, material inside, and everything keep as it is. Okay, that's it. Now again choose edge flange, select this outer edge and drag it inside. See, it's going inside. The same thing, select this all edges, just tilt this side, second, third, fourth. Now all going inside, and we will keep everything same as it is, even width, bend also 30 mm, and everything same as it is, gap and by default radius. Edge flange, select, drag upward direction, select here also the edge, and this is the actually last one. The last one we will define a small 20 mm. Now look at the joint. Okay, now see how it looks from the inside. Now this area you need to weld it. Now let's try some hemming tool also. Hemming, select outside and keep 10 mm, and here choose closed. See, this one, let's choose all the sides. And that's it. We want to keep this hemming inside. Let's select OK, and you will see the hemming outside. Hemming, why we put hemming here? Just avoid the sharp edge, but this hemming we want inside. So at another click edit feature, and here you can select reverse direction. See, it goes inside. Okay, that's it. The hemming, it's gone inside. Now it's time to add some color. We will add some dark color. keep this one, go to appearance. Here you will find solid materials, select yellow, then comes here near any okay. Now choose your flat pattern, and you will see this is your sheet which is ready for the sheet metal works. After preparing this, you can put this sheet in turret punch machine, where you can cut this way this sheet, and you can bend according to the line. Exit. Now let's save this one. Go to desktop and create a folder, Almirah, part 1 mainframe. Save it. This is the main frame of Almirah. Let's make the other parts of Almirah. Even if you want to define these parts, you can go to Solidworks MBD, choose smart dimension, select these two faces, and that's the dimension. Back face. So this is how we will use to create the dimension on 3D product. Let's save this one and let's see the other part. Here the next part is rack, the shelf. You can say the shelf. So let's start with let's front plane sketch, center rectangle, and draw a rectangle from origin point. Smart dimension, let's define this 608 millimeter, and the keep vertical length, it's 410 millimeter. Now go to sheet metal and extrude. Okay, keep thickness 0.6 because we took all the dimension, all the sheets 0.6 mm. K factor keep as it is. Okay, now let's choose edge flange. Select this side. Now here select all these 4 edges. Default radius keep as it is. If you like to change, you can change it from here. Gap I'll prefer 0.5 millimeter. This is too big gap. Even you can, if you want to reduce 0.3, you can see it's reduced. Even though you can make 0, see there is no gap, but very difficult to make the 0 gap geometry. 0.3 mm, 90 degree, 20 millimeter. See, now here what we will do, change default radius, keep it small, 0.5 millimeter. Then you will get the edge perfect. Otherwise, if you will change it, see 1 millimeter, it's quite big. It's 0.5, that's fine. Select here OK. Edge flange. Now select this outer edge, take it down or even upward direction. Let's make 20 millimeter. Here you can select reverse direction. Default radius, let's change it. See, it's too big, 0.5 millimeter. Okay, now that's it. So this is the simple shelf. If you will open this one, just click flatten and this is your material ready, unflattened. Dark color, I'll go for solid green. Okay, flatten, see, exit. So this is our rack, or you can say shelf. Save it, part number 2, rack. Let's check other parts. Now here let's make the door, third part. Choose top plane, sketch, center rectangle, smart dimension 850 millimeter by 545 millimeter. Go to sheet metal and keep the thickness 0.5 millimeter as it is. Okay. Now let's choose edge flange. If you will choose select here upward direction, select all the edges, all sharp edges. Now here select now we want to cut in one side, so we want to delete one edge. Select delete. Look at this, one edge we want to delete. Radius, if you like, you can keep default whatever, 0.3 gap, and edges extrude keep 28 millimeter. Material inside, virtual sharp edge. Okay, again choose edge flange. Now select this edge, keep inside. Look the inside material. Here also let's check out from outside edge. And thickness, let's make 20 millimeter. Okay, that's fine. Radius, everything keep default. Okay, now here we want to cut. Let's make some hemming also. Hemming, keep outer one, cancel it. First we will make one edge here. Reverse direction, and this edge actually we need 12 mm. Look at this. Select here OK. Look, now try hemming. Keep close, 10 millimeter. Select outside edge, select here also. We want to keep hemming inside, so reverse. See, here it goes inside, and even though here also it goes inside, keep 10 millimeter, and here choose material inside. Okay, that's it. Now we want to cut here a taper cut. So how we will do, choose here unfold command. This center face keep as a fix and bend to unfold. Here the first one, second one, and the third one is this hemming. Select this hemming, go to opposite direction, hemming this corner, and rotate and bottom one. Now we already selected 6 edges, we want to open it. Select here OK. Now let's see how it's going to unfold. We don't want to fold this one. See, this edge is unfold. Select this face, sketch normal. Now here we want to cut some edges, so choose here line, define it up to here, connect it. Here we took center point of this edge, so no need to define vertical length, 85 millimeter. Okay, choose here line, now here select this corner, select 85 millimeter. Okay, now go to sheet metal, choose here extruded cut, keep link to thickness so that it will cut only up to thickness. Okay, that's it. We cut it both direction. Let's define some material red so that it looks visible. Now choose unfold command. Now we want to fold this one, so select this edge, and third this edge. Select the opposite direction, go to opposite direction. Here the fixed face we already took this center one, in bend to fold, fourth, fifth, and this is the last one. Now we took the all edges what we choose for the unfold. Select here OK. Now it's going to unfold, it's going to calculate, and it's taking time. I don't know. Okay, now look, how it's unfold. We cut a taper shape here, that's perfectly done. Now let's flatten this pattern. And this is ready for the sheet metal works. You can now make a CNC program and you can cut it in CNC turret machine. Look at this. Select here OK. Okay. Select save. Part number 3, door. Here we want to create a hole, but later we will create here hole. Let's make the first part of hinge. Top plane, sketch. Draw here a circle. That's it. select the line, exit, choose this line and make sure it is horizontal. Let's define the length. Our diameter, let's keep outer diameter 15 millimeter and inner one 3 millimeter. Look, that's fine. 10 millimeter. Okay, now choose trim entity, power trim, and trim this one. Look at this. Okay, now select extruded boss base and extrude up to 2 millimeter only. That's it. Okay, now select this face, sketch, normal, choose here corner rectangle, draw a rectangle, select this corner and this corner, merge, coincide. Let's define the length. Keep the length 64 millimeter. Look at here. Extrude. Extrude only 2 millimeter. Direction 1 keep 2 millimeter. Okay. Now we want to mirror this one in opposite direction. So how we will do this one? Let's create a plane. Choose this top face. Oh, sorry. We want to create a plane actually. Plane. Select this surface. 32 millimeter. Flip offset. See. Okay. Now choose this plane 1 mirror and select this part. Extrude 1. Even you can choose it from here. Extrude 1. Okay. Let's it. Hide this one. And let's make some alternate color so we can easily identify this color. Let's make green. Okay. Save part for hinge. Hinge part 1. Let's make the other part. Now here let's make the next part of hinge. Front plane, sketch, choose your line. And draw a taper line, little angle. Let's define this one. 25 millimeter. Angle 135 millimeter. Keep the full length 30 millimeter, 10 millimeter. 10 millimeter. 5 millimeter. Let's define this angle. 135 degree. Sorry, this not mm degree. Keep this angle 130 degree. Look, this looks nice. And define the length 15 millimeter. So this geometry is fully defined. Go to sheet metal, base flange, thickness. We want to make the width 60 millimeter. Okay. Let's keep thickness point to, that's fine, 0.6 millimeter. Radius as it is. Thickness let's make bigger because it should be more thicker. Select here OK. Now select this face, sketch, normal, draw here 2 circles. Let's define this. 4 millimeter and inner one 2 millimeter. Okay, select this corner and this radius, select coincide. The same thing, select this radius and this corner coincide. Now see, the drawing is fully defined. Go to feature and select extruded boss base, 60 millimeter. Choose reverse direction and make sure merge result, so it will merge with this body. Okay, sheet metal, flatten. See, this part is actually ready for the put it some green color. Okay, unflat. Let's save this part number 5, hinge part 2. Save. Now here let's start to make handle. So for creating handle we need to create a curve shape. So first we will create some multiple number of planes. Choose here top plane. First plane, let's keep we will keep the multiple number of planes. So first plane we will select 11.5 millimeter from the exact top plane. Now choose plane 1, again plane, and this plane we will make 71.5 millimeter offset, that means backward direction. Okay, again choose plane 1, plane, and plane 25 millimeter, plane 3. Choose here flip mat, plane 1, plane, (120 millimeter). Choose here flip mat. Okay, actually this plane 3rd should be below the plane 2 and in place of plane 2 actually. Okay, let's we will manage with this. Choose plane 1, sketch. Let's draw a center line. Make sure it's vertical. Corner rectangle. Select the center point and this line, merge or coincident. Now let's define this dimension. Now here 28 millimeter, 23 millimeter, 7 millimeter. See, exit. Now let's choose plane 2. Is plane 3 actually, sketch, normal, corner rectangle, center line. Now select this center line and select all the outer lines. Here you can create symmetric relation. Let's save the same thing. 23 millimeter, 7 millimeter, and the distance from bottom edge This one keep 35 millimeter. Now look at here, exit. Now select this plane 2, sketch, corner rectangle. Let's define this plane 2. 24 millimeter, 7 millimeter, and the distance from this, let's make distance from origin point 38 millimeter. 24, so distance from here 12, so it comes in center position. Look at this, exit. Now select the plane 4, sketch, corner rectangle. The last one we will keep is smaller, 16. Height we will keep same, 7 millimeter. Normal. Distance from bottom edge 28 millimeter. Okay, now select this center point and origin point, make relation vertical. Now see, it's fully defined. See, exit. Now let's choose here lufted boss base command. Now here we will select the profile. So do one thing, select all the profile and choose one edge, this corner, second one, here the third one, and here the fourth one. So it took a particular kind of a kind of shape. Sketch 1, and here choose normal to profile. Let's check, normal to profile is not actually keep default, that's better. It select OK, no need to define anything. Now select all the lines, all the planes height, that's it. Choose front plane, sketch, normal, circle. Let's draw here a circle in front plane. .9 millimeter. Or let's keep it smaller than this line. Okay, that's enough. 22.9 also. .88 millimeter, that's fine. Extrude, reverse direction, choose up to surface. Now select this surface. Okay, this little overlap, that's fine. Select this face, sketch, normal, choose here line, select this point, connect it, select this circle, convert entities, choose power trim and trim this half circle. Now here it's, now this portion we need to delete it, so extruded cut, select here through all. Okay, look, it looks nice shape. Select this face, sketch, normal. Let's define a radius. Now here we want to create some extrude part. Let's say 16 millimeter, and extrude up to 16 millimeter. Okay, now here we want to create a hole, so we will create with the help of hole wizard. Select here hole, ISO standard, drill size, and diameter let's keep 9 millimeter, and depth we want to make 40 millimeter, and here we want to create some counter 90 degrees 12 millimeter. Choose position, select this center position, select OK. Now look, the hole is created here, a nice hole. Select this face, again sketch normal. Now here we want to create, or actually we want to cut. First let us draw a center line. Select the line, make vertical relation, corner rectangle, draw a bigger line. Now select outer and middle and choose here symmetric, and define this one 3 millimeter. Make sure it is bigger than this outer radius. Extruded cut, $12 millimeter. Look, center rectangle, draw 8 millimeter, 8 millimeter. Extruded cut, make the depth 35 millimeter. It looks nice. Choose here fillet, keep 2 millimeter, and let's try this one. Select two faces, select third, fourth, fifth, and sixth. Okay, choose here the last one inside, keep 5 millimeter, quite bigger. Okay, this looks perfect shape. Now here that's enough, don't need to make any threads or something like this. Actually if we will make thread it looks original, but that's okay. We are not doing perfect model, so choose here steel satin finish. Let's save part number 6, handle. Now it's time to assembly for the Almirah, so let's start. Now here let's start to make the assembly of simple steel Almirah. Choose new assembly. Okay, now this is the Solidworks assembly window. Let's browse our first part. We will keep mainframe as a first part. Plain white background. Let's insert the other parts. Rack. Now let's rotate this rack. Again choose move component, take it out, select here OK. Make sure this portion should be outside. Now choose mat, select this side wall and inside wall, make relation coincident. Okay, select this wall, take it out, clear. Oh, take it out, select this side wall, mat, inside wall. Okay, select this top face and this face, choose here distance, and the distance we will keep, it's around 304.8 millimeter. This is the center distance, that's why we kept this one. Okay, cancel it. Now press Ctrl key, copy one more, mat, select this backside wall of rack and inside coincident, mat, inside face and this side face coincident. Okay, select this face and this face, keep here distance 304.8 millimeter. It is the center distance. Okay, cancel it. Let's bring the hinges. You can increase extra large icon, select these two, male female or hinge 1 hinge 2, 1 2. Now let's rotate first this part. We will fix this part first. Okay, choose here mat, select this inside and this side, make relation concentric. Okay, go back to advanced mat, choose here width, select this face, this face, this face and this face. Now it is comes in center position, select here OK. Again go to standard mat, drag it here, where exactly? Okay, select this side wall and select this wall, make relation concentric, a coincident. Okay, now select this inside face and this face, make relation again coincident. Okay, now it's time to make some distance. We need to actually define some distance. Now select this face, and this face, choose here distance. Now here we need to define some distance, 120 millimeter. That's perfectly fine. Okay, okay, now let's mirror this one. So how we will do it, just choose, okay, let's do it linear component. We need to choose a one direction, so I'll choose any one perpendicular direction. Let's see this line, direction 2, don't need, component to pattern 1 2. keep here distance 300, 600, 550, that's better. Okay, now it's mirror here. Insert component, browse, and choose your door. Rotate. Okay, we will keep like this. So this small portion should be going to fix with this, with the hinge. Okay, choose mat and select this face and inside face, make relation coincident. Okay, the same thing we have to do back side. And where is the hinges? This hinges coincident. Drag it. Just cancel it and let's move it actually. Okay, let's try to define some distance. Let's select this end with this end. Sorry, mat this end with this end. Let's check where exactly the model. Okay, now here choose gap, and the distance we will define some small distance like 16 millimeter. Okay, go to advanced mat width option. First select the box outer, this door outer, both faces. Now it's fixed in the center position. Okay, now see, it's rotating because the hinge is already fixed here. See, now it's time to define some angle. So go to mat, just go to advanced mat, angle. Here choose two faces, 1, 2. Maximum angle 130 degree and minimum 0 degree. 130 degree and 0 degree. Select OK. Okay, now let's open and close door. See, now it's not going beyond this. Open 130 degree, close, open, close. See, now something balance, insert component. The last part is handle. Handle actually supposed to be, it should fix in a in like this way. Okay, select this door, open, and we want to make some hole here. Select this face, sketch normal, hole. and keep the diameter 16 millimeter, distance 215 millimeter. Okay, center point. Now go to sheet metal, extrude cut, clear. Here choose blind, link to thickness. Okay, it's going to save actually. It's taking time, I don't know. Oh, that's fine. Now the hole, hinge hole or handle hole is fixed. Cancel, selects yes, save, choose met, select this whole surface or wall, select this one, make concentric relation. Okay, select this face, select this face. Okay, now it's rotating, so we will fix this one. A standard, select lock, select this body, choose lock. Okay, we need to fix two surfaces. Okay, now it is locked with this surface. Let's open the door. See, this is the our simple Almirah, a steel cabinet, or you can say Solidworks MBD, and choose here annotation. You can write here door. You can define this all dimensions like red, then change. Okay, again choose this. This is the main body, main frame. One, 16, that's it. Okay, oh sorry, I forget to. Anyways, let's define some dimensions. Smart dimension. Now here dimension export location, select these two faces. Okay, now select this top bottom faces. Okay, in the same way you can define multiple number of dimensions. So I hope you like this tutorial. Don't forget to share and like our video, and please subscribe our channel for more video and more projects in SolidWorks. Thanks for watching.